Feature engineers. Today we're looking at bode plots. We're looking at poles, zeros, and graphing out the magnitude graph and the uh, angled graph or phase graph. The problem is you first put your question into standard form. Standard form is where there's a 1 plus JW, which probably would be having a fraction, because questions usually come out like for this part, it's probably going to look like that when you get a question, and you need to convert into all of them having only ones. Once you do have it in standard form, you need to look at all the different poles and zeros. So anything in the numerator is called a zero in this kind of form, and anything in the denominator is called a pole. I actually forgot this from the question, so there's a 10 up here. And you write out your poles and zeros. So the poles here would be 10, 1, and 50. You get that by looking at the denominator of each JW. And this would be 1, and that would be 50. After that, those are your x values, right? And you need to find the initial point where you start. So the initial point here, you might have seen me erase it, but that is your constant, just a standalone number. And the way you find your initial point is you do 20 log of 10 or just log and your initial point. This here will give me 20, which is why we start at 20 decibels. From here on out, it's kind of simple to just graph it because each zero represents a plus 20 decibel increase and each pole represents a negative 20 decibel increase. Now, you might have questions where your poles or zeros are squared. This is a quadratic pole or zero, and instead of doing 20, you'd do 40. So, for example, if that was squared, you'd do negative 40 decibels of change. Now this is over a decade, and a decade is just one unit of like going across the x-axis on this axis. Remember to write the correct units, because this is decibel and that's radians per second. It's not a very common graph that we do. So I'll actually erase both of these because this isn't something you can just assume straight off the bat, but this is something that you start with. So we know our starting point, which is 20 decibels. From here, we know our first interval is a 1. And what is a 1? A 1 is a pole. So a pole is negative 20, so I'm going to go down by 20. So 20 minus 20 would give me 0 decibels. Remembering this 0 decibel point is important because this changes our phase graph a little bit. So from here, we look at the next one. So 0 is a 10, 10 is 0, and so it's going to go up by 20, negative 20, plus 20 is just going to be 0, so it's just a constant line. I'll make that pretty shaded. And then from there, we have another pole. It's going to go negative 20, and that's where you end. If this was a quadratic, the question, this isn't a quadratic in the question, you would do negative 40, and so you would end up at negative 40, but we don't here because it's not a quadratic. For the phase graph, you want to write out like the angles, common angles like 90, 45, 90, 45. And a 0 corresponds to a positive 90, whereas a pole corresponds to a negative 90 degree change. And if it's a quadratic, you just do a 180 degree. So if it's a 0, it's a positive 180 change. If it's a pole, it's a negative 180 change. From here, you would technically have to look at the poles and zeros and follow the same steps as you did for this graph. But what I like to do is I just like to infer from this graph. So you would start at if you have a constant, you start at 0. If you don't have a constant, we'll go over that later. Actually, let's go over it right now. If you don't have a constant, you start at 90 degrees initial, and you don't have to find the initial point. So for example, if we didn't have this 10, technically you're multiplying it by 1, but don't worry about that because log of 1 is 0, right? And you wouldn't get it anywhere. So you just assume 90 degree for the phase angle. So we would start at 90 if there was no constant, and you would just look at the lowest pole or 0 to find where it starts. So if we didn't have the constant, then our lowest pole or 0 is a 1, right? and a 1 car and the pole at 1 corresponds to a negative 20 decibel change. So you would start at negative 20 instead. Or if it was a quadratic, you'd go negative 40, or if it's a 0 quadratic, you'd start at plus 40, blah, blah, blah. So let's look at the question. We're now starting at 0, but you should have remembered that I told you to keep in mind the 0 decibel line here. At the 0 decibel line, so wherever at the point wherever you hit the 0 decibels, so here it would be the 1. At x equal to 1, you're hitting 0 decibels. At that point, you want to connect to 45 degrees or negative 45 degrees, whichever is closer. So in this example, we're starting at 0. We're going to go down by 90, but there is a 0 on the way here. So what we're going to do is we're going to go down. Technically, go down till here, that's 90, right? We go down till negative 45, and we just connect to this. And then from there, we would either go up to the next 0 or the 90. So we would go down or up in increments of 45 just for this segment. So from here, the next segment would be, let's look. The next segment is a pole, or sorry, a 0. So that is no change for now. So this is going to be constant. I say no change because we would only go up or down if it was a quadratic 0, which is 40, sorry, if that's 180 degrees plus, or minus 90, which is a normal pole. That the 0 part is just kind of weird. You just need to remember it as like a connecting area where you go from where you touch 45 degrees, and then from here you either connect to 90 or you go up to the next 0 or 90. From here it's straightforward. We're going to go down to the next 90 because this is a pole. That's how you do bode plots. There's not much else to it. It's just finding the poles and zeros, using those as your x values, and then from there you're able to go down by negative 20, positive 20, 40, or whatever else. That's bode plot.